So what I'd like to do now is segue right into our first fireside chat and welcome Eric Schmidt up to the stage. He doesn't really need any introduction, really, but just to remind you, he's the former CEO of Google.
Hi.
Hi, Eric, former executive chairman. Here, have a seat. And he's now technical advisor at Alphabet, Google's successor or parent company. Longtime friend and supporter of the Initiative on the Digital Economy, so we're grateful. He helped shape some of the agenda that you're here about today, our overall plan. So, Eric, welcome. And I'm going to ask him a few questions, but I also will leave a little time at the end if any of you have a question or two that you want to ask. But let me start off by just going back, as I did in my talk before, going back to some of your past history. You were initially at Bell Labs and Xerox PARC. Then, of course, at Google, and I think you're on the board of Apple. You're doing a bunch of ventures with, is it innovation? Yes, innovation endeavors. You're a venture fund, so you very much have your finger on the pulse of current technology. That's quite a sweep. You have a unique view of how technology has evolved, how Silicon Valley has evolved. How has it changed? Those were some icons that you were involved in early on, some icons today. Are they similar, different? What's happening with technology?
So I wish I could be as clear and coherent as your initial presentation. You've got it so right in terms of the digital economy getting larger and then all of these consequences. And I can tell you that when I started, as I guess most young people would be, none of us anticipated any of this. Right? So it took visionaries like Steve Jobs, right, to see scale and impact of the kind that we've seen. But most of us were simply computer scientists working on interesting and hard problems. So what I learned was that you should spend your time working on network platforms that are interconnected and that scale fast. So as a simple principle, do that in life.
That worked for Google pretty well.
It worked pretty much everywhere in my entire career. So if I go back to Sun, where I was for 14 years, we invented a slogan called "The network was the computer," which seems archaic today, but at the time was considered revolutionary. When I worked at Berkeley, I worked on the first version of networking in the form of TCP/IP networking for Unix. In every case, networks were the power source of innovation, of connectivity, and so forth. So if you think going forward, the next 50 years, what will be true in 50 years? More deeper, more powerful networks of humans and computers interacting together. And all of the consequences will come from network laws, network power, network effects of one kind or another.
Right. It's something economists are sort of now discovering, or some of us rediscovering. There's been a literature, but now they're beginning to give Nobel Prizes out to people like Jean Tirole for understanding the power of networks and two-sided networks.
What's interesting, and you did a lot of work on two-sided networks in an earlier version of yourself, the problem with networks is that people have trouble with power laws.
Yeah.
And they don't fundamentally understand how uniform and universal power laws are.
That's right.
So if you look at connectivity of cities and connectivity of telephone networks and connectivity of your friends, they all follow a certain mathematical structure. People in this audience at MIT would know this. The average human being is surprised by this. And so the political discourse always finds an edge case that looks strange relative to that produced by some form of power law connectivity.
Well, it is, and the power laws is a good description. So power laws have these long tail. There's a few winners and then a long tail. And in work I did with Guillaume Saint-Jacques, we saw that the income distribution is moving from kind of a normal or log normal distribution where there's people on either side. If you are twice as dexterous, you might make twice as much money as a waiter or as a bricklayer. But with digital network economies, the winner often makes 100, 1,000, 10,000 times more than the next best person.
When I first heard this principle from a fellow named Nathan Myhrvold 30 years ago at Microsoft when he was first there, and we were talking about how the PC market share was shaping. And it was, in his view, 90%, 9%, and 0.9%. And I said, that's not true. Market shares are always 60-40. And I remember thinking, he was the first person to me who said, this thing has a different shape because of the nature of how the distribution networks work.
Well,
I should add one more thing. Is in my first few years as CEO at Google, I at the time, there was this notion that there was enormous amount of revenue and connectivity in the tail of the distribution, that the advertising markets were well served in the head of the tail, because they had direct salespeople and people knew the brands and so forth. And that one of the things that we were doing was we were discovering this enormous number of underserved small businesses and so forth. And that's all true. But our mentor, Hal Varian, did a study, this is again more than 15 years ago, and said, but there's a lot of revenue at the head, right? And ultimately, the key thing about networks is that you have to study the actual slope and shape of that. It plays out in other things. So for example, NBA basketball stars, university tuitions, university application rates. And the key business question is, if you're at the very tippy top of a network distribution, you should be able to continue your strength. But if you're in one of these parts of the curve where you're getting pushed down because of another network, what do you do? And that is, to me, the hardest business problem that venture capitalists and entrepreneurs face.
Well, you've been lucky or smart to mostly be up at the head of that. I mean, I know that Google wasn't always a giant company. You joined them, well, it's 2001, I think you became the CEO there, and it was one of the small companies at the tail. So what are the strategies that work for you to help move up, and are some of those things that people in the audience could learn from?
One of the things that's worth saying is that there are better approaches, there are better engineers, there are better scientists, and if you can get a sort of a good share of them, you can make progress very quickly. The thing that was most bizarre to me joining Google was that it didn't have a normal product schedule. I had grown up in the principles that were invented here in Route 128 by Digital Equipment Corporation, Data General. The people who hired me and taught me were structured, organized engineering managers. None of that was happening. It was literally a rush, right, to what was possible. That is now the model. So when you go,
so they were doing it right.
Well, and today,
or at least it worked out.
And today, the companies that are the biggest ones have relatively informal product strategies and a whole notion of speed, right? So there's a book. I was going to say that our mutual friend Reid Hoffman has just published a book, which I encourage everyone to read, called Blitzscaling. And the basic argument is ignore all of the rules that you've been taught about how business works and just run super fast into a new market. And if you're confused about that, I'll give you an example outside of my own industry. Look at Tesla, right? So Tesla spends all day being criticized by everybody else, and yet they've gained share very rapidly using these techniques. There are plenty of examples.
One of the things Reid says that's a little controversial is, if you're not embarrassed by your first product, you've waited too long. Would you go that far, or do you, because were you embarrassed by the products that Google came out with?
Well, in fact, that was our rule.
Yeah.
And back when we could do these things, we had a rule that everything would come out in beta, because we didn't want to have to defend some of the mistakes.
You'd put beta, so you'd say, and so, don't blame us.
People forget that Gmail came out on April 1st of, I think, 2004 in beta. And we forgot that we'd kept it in beta for so many years. But the important point about it is...
Is it out of beta yet?
I think someone eventually took it out of its misery. But the point is that it was a signaling that that this was experimental in a really powerful way. It was part of the bargain with our users.
And this gets back to your point about networks. I mean, there's something in network theory called the preferential attachment model, that those who have much get more, and they're more likely to get additional things. So if you can get out there and start building your network.
Well, and in fact, the way we did Gmail was interesting, is we did a seeding strategy. So the first people who used Gmail were employees, and then we had friends of employees, and then we had friends of friends.
They would send invitations,
and
so
you're invited to try it. And people were constantly after me to get invitations. And that was a pretty good signal to me that we had a winner here, right? Of course, the rest is history.
So you had a couple of strategies.
So the way to say this is, the world is so competitive now that if you think you have enough time to, quote, fully finish your product, you're going to lose, right? You have to understand the global competition, and for many reasons it's more competitive. There's a great deal more information sharing. There's a great deal more labor movement between things. What I tell people when they start a company is, you have to figure out who started it, the same company the same week, and figure out how you're going to compete with them.
So a corollary of that must be that you also have to be able to course correct quickly and learn from the mistakes that are in your beta. And for centuries, people used to make decisions by getting all the smart people around a table and everyone give their opinions, and then they would go with the hippo, which many of you know is the highest paid person's opinion. But now we're much more of a data-driven approach. And you wrote in your book, How Google Works, about using data, experiment and test. Talk a little bit about how that fits with this moving fast strategy.
So the internet, the internet is a metaphor here for we're connected to everyone all the time. If you're connected to everyone all the time, you should be able to get instantaneous feedback all the time. A correctly engineered product of any kind is giving telemetry and so forth about its use, and then strong engineering teams are watching and saying, oh, that was a bad idea, that was a good idea, let's do more of that. And
tell us about how you're doing A/B tests a lot in real time.
Again, this was invented, and the person who did most of this was Marissa Mayer, who again, ultimately ran Yahoo for a long time. And her basic theory was that we couldn't be sure about what the right UI was, but we could certainly test it, right?
Right. Should it be blue shade or a darker blue shade?
And so what we would do is we would have an A/B test, a straightforward A/B test like you would see in a normal industry, where we would have a control group and then the change, and we would measure it. And we would always keep a holdback. We would often do essentially 1% tests. So we would do a 1% test. And eventually people figured out
1% of the users got exposed.
1% of the users. And eventually the press found this out, and they would report breathlessly, Google's doing a test, right? And sometimes there would be follow-up like, oh, there's a product. And sometimes it would be lost in the dustbin of bad ideas. But the key thing to do was that the decisions were, the tracking was done analytically. And I believe that this sort of this measurement concept is a key to product success in every industry, not just in Google's.
So I can definitely see how that works with sort of small incremental changes like the UI. In a way, Alphabet has taken that to the level of whole business ventures. Does it work when you scale up that? And what are the limits to this? Is there some point where it doesn't make sense to do that kind of testing? Are the units just too big?
It has more to do with the nature of the technology. Software is sort of the biggest invention of America, largely because it's so flexible. There are plenty of other industries which have extremely high capital costs. So for example, we can't build a $20 billion fab line and then test it and then decide it was a bad idea.
Right.
It's just a bad business idea. But we can do incremental tests along the way. In other words, we can have a single machine to test a particular kind of lithography, and then based on that, generalize. So the testing mechanism does have to be adapted to the capital costs of your industry and the nature of your customers. But one of the things that people complain about this is things are changing all the time. But things are changing all the time because the companies are becoming more competitive with each other, and that change is making them more efficient. And it prepares them for global competition, et cetera.
One of the things you did at Google was shifted it to be a mobile-first company, and with Android, and obviously that's a huge platform for everybody right now. It's a big part of the internet. Most of us interact more with that through the mobile internet. But a couple of years ago, you went another step. You changed to AI first, and Google Research became Google AI. Is that different from networks? And what does it mean to be AI first? Why are you shifting in that direction?
In a relatively large company, as smart as the people are, there become these sort of orthodoxies, right? It becomes impossible to change core beliefs. So an example in my case is I would run around and look at product reviews, and I would get a demo of a mobile product, but they would show it to me on a Mac or a PC, right? And the reason was that the tools on the mobile device weren't good enough, and their development environment was on the PC, right? And that doesn't produce the best outcome. The core rule about development is you need to, the old phrase was you eat your own dog food, was the one that we used to use many years ago. And so what I ultimately said was, we need to be mobile first. And mobile first meant that the best things came out on mobile, the first things came out on mobile. Now today, that seems like duh, right? And indeed, if you look at the internet startups, they're essentially all mobile first. They typically, a simple example would be Instagram. They typically have much stronger apps on smartphones, Android.
Right, they don't even really have a desktop app.
They do, but it's not as functional,
Okay.
right? Or it's used for other things, or they'd use it to treat an enterprise customer. So when Sundar came forth,
Can you say, like, I don't know if this is reported, like, what share of Google search is mobile versus desktop? Is it?
I don't know the percentage numbers, but it's grown very, very rapidly, and will continue to do so. So people have moved to mobile. And so we were right about that transition. And as you said, these are general purpose technology trends. The fact of the matter is, for the next 5 to 10 years, the vast majority of your digital experiences will be on mobile phones. And the vast majority of those will be Android, by the way.
Do you know the market share there?
Analysts report our market share is extremely high. Anyway, I'll let you look it up.
You don't want to make news today on that.
I can assure you it's much, much higher than you think it is, and growing very quickly. But the important point is that for the next 5 to 10 years, the vast majority of digital experiences will be on mobile, partly because of the nature of the technology on mobile, and also because of the spread of mobile smartphones in the developing world, which is, I think, one of the greatest achievements of our industry. Because think about it, you're in a relatively poor area in a developing country, and the smartphone shows up. It is life-changing, and we've talked some about that.
Oh yeah, no, we see so many of the Inclusive Innovation Challenge companies are a very common variant of the model is using these mobile phones in Africa or India to connect people to the global market in a way they couldn't have been connected before.
And if you think about the numbers in Africa, are quite interesting. Today's Africa is roughly 14% of global population. The current forecast by 2100 is it'll be 39% of global population at an 11 billion population. So that's an awful lot of mobile phones, and that's an awful lot of connectivity. There's an awful lot of people who will be inventing, building services, doing new companies, and so forth and so on over the next 100 years, 80 years. So in any case, so machine learning comes along, and it became clear to us that your argument that this machine learning thing is a general platform was true, in the same sense that phones were, the same sense that the internet was. And so the company decided to focus on AI and machine learning.
So I kind of get mobile first means that you develop, in part, it's a strategy, but it's also a literal tactic of first rolling things out on the mobile device before the desktop.
And
what is it? Yeah, what is
and
AI?
AI first is that every product should have a component of AI in its design. And software systems that are networked are particularly applicable to this, because in software systems that are analytically well designed, there is a feedback signal. And with the feedback signal, you also have training data. And the machine learning world is very, very sensitive to the amount of training data. And we can talk about the implications of that.
Yeah, we should.
But these digital companies generate a tremendous amount of training data all the time, which they can use to improve their algorithms. Think about Netflix recommendations, right? Remember when that first came out? You go like, oh, that's kind of cute. Well, it turns out those recommendations, which they today use machine learning to produce, are incredibly important to this business model.
Right.
Because the studios that they compete with don't have the ability and the knowledge of what to recommend, right? Amazon recommending products, it's the same argument. So one of the things that sort of subtly happened was we all started using these recommendation engines, which today are machine learned, without really thinking about it. And why did we use it? Because it made our experiences better. The recommendations were good. It allowed us. So today, if you look at YouTube, the majority of YouTube usage is people who watch one video and then they watch a following video and a following video that is recommended from the first one, right? That followership turns YouTube from a 3-minute thing to a 30-minute thing or what have you.
Yeah, in some ways, your social network at Google didn't really compete with Facebook's, but YouTube is a kind of a social network in some ways.
Yeah, and YouTube has been fantastically successful in that regard.
Yeah. On the Netflix recommendations, I mean, this is one of the real successes of machine learning. For me as an economist, one of the flabbergasting results was when they did a test of comparing, they asked a group of people to pick what movie they want to watch that night, and then another group, they said, no, you don't pick, our recommendation engine is going to pick. And then afterwards, they asked them how much they liked the movie they watched. And I would have thought as an economist, the one thing that we could do right was like know our own preferences. It turned out that the ones that were recommended by Netflix, people were happier afterwards than the ones where they picked themselves.
People have an enormous sense of their own analytical judgment, right? And I'm sure that isn't true here at MIT, but at least the rest of people. And so what we know from machine learning is that there are subtle patterns that computers can detect in the training data that we just don't see. And it's really a math problem that these systems can go backward in time, and they can go backward in time deeper and more subtly than we are. The famous example inside of Google is our data centers. We have the best engineers in the world, according to us anyway, and they are busy building these data centers, and they do a fantastic job. Using reinforcement learning and some of the DeepMind technology that you mentioned, we got a 15% improvement in energy efficiency by studying the patterns of use of our data centers that was not apparent to the traditional algorithms that our teams of top engineers were finding.
Yeah, that was an amazing result. Some of those, DeepMind got a lot of attention for the video games and the reinforcement learning beating Atari, but then they took that engine, that reinforcement engine, and applied it to a real-life video game, which is how do you optimize energy in a data center.
And you sit there and you go, how exciting is this? When do you turn on the cooling? When do you turn on the fan? Well, it turns out if you have enough computers, that's super exciting, especially if you're looking for energy efficiency and savings. Apply the same principle to the US electric grid.
Right.
And think about what that could do for the things we all care about.
15%. Yeah,
imagine if that were translatable.
And ultimately, any kind of continuous manufacturing, any kind of process where you're optimizing. I mean, at the Sloan School, we have a whole army of people doing operations research, but if they were enabled by or complemented by some of the reinforcement learning tools, you could get a lot more efficiency.
And it's important to understand that MIT gets this, that not only is there very fundamental research on all of this, but with the new college that was so generously donated by Steve Schwartzman, there'll be a huge increase in the resources and people who can apply these tools to fields that would traditionally not be able to get those kind of resources to do research. So whether it's political science or linguistics or so forth, places where you don't find computer scientists wandering around the hallways, the college that Steve and company are donating, which is an extension of the Quest activities and so forth that have happened over the last year, that all those resources will be applicable to doing things. And in each of those fields, the most interesting cutting-edge research is because they're now getting access to data, right? Economics, as you know, as an econometrician, has had access to data of one kind or another for decades.
Small data.
but nevertheless, economics went from being a sort of a thought experiment to a data experiment.
That really transformed the field.
Over the last 30 years. The same thing is about to occur in the other aspects. And in the leadership, by the way, in the country is here at MIT.
Well, so let me see. We only have a few minutes. There's a couple different directions, but let me follow up on a quote I heard you quoted last month. We both spent some time in China. You were quoted as saying, the internet will split in two by 2028, if not sooner. What does that mean?
So the only problem with that quote is that headline is completely not what I said.
Okay. You're here to set the record straight.
So by the way, there's no mention of 2028 in my comments.
In the headline there is.
But please, if you care about this, read the actual thing that I said. So let me say what I actually said. The most interesting things that are going on in the world today are this huge phenomena of success of internet companies in China. And we have historically in our industry tended to dismiss them. We've historically said, yeah, they're in China, it's a bubble, and so forth. That's clearly wrong. The scale, the opportunity in the market, the creativity, and so forth, and that set of companies are well worth watching. And it sets up all sorts of questions about what happens, where do they go, how do they interact with the government, how does globalization occur, how do they expand outside of China, and so forth.
So in a minute, if people want to line up the mics, I'll take a couple of questions. But let me, before we go to that, just ask you about the Schmidt Science Fellows. You announced that about a year ago. What's your goal there? What are they?
So in my personal philanthropy, I decided to focus on a couple of things. I'm very interested in talent at the postgraduate level, people who've just finished their PhDs. So we set up a program with the Rhodes Trust to identify people who were brilliant people with PhDs who wanted to do something else that was interesting or related. And so the typical example is we funded a fellowship of somebody who is working on, they're trained as a PhD in astrophysics, and they want to work on observing cancer. Right, so it's those kinds of analogs.
Yeah.
So far, the feedback has been fantastic. The initial crew is fantastic. We're obviously going to continue this and expand it.
That seems so exciting. I mean, if you look at the Kaggle competition that Google bought a while back, the thing that was very striking was how almost every time the winners of those competition were from people from outside the field. And that seems weird, but if you think about it, the people inside the field have been working on the problem for a long time, and if they're hitting dead ends, it means you need to come in with a fresh perspective. So this idea of getting people to move across fields and bring new tools sounds like it could be very productive.
Yeah, and I think, if you think about what is on a go-forward connected world, what is the core problem, is that even the best universities are stovepiped. Even then, people are pretty narrowly tracked. People are not necessarily familiar. So the more that all of us can do to encourage interdisciplinarity, the better.
Great. So we just have a couple of minutes left. If you guys have a really quick question, it has to be a question and really quick, we'll get Eric to respond. Let's start over here.
Hi, my name's Ryan. I'm a computer science teacher in Massachusetts. So given that machine learning and AI is going to be in all these kinds of fields, especially ones that affect finances and health and safety of people, would you still recommend this idea of blitzscaling, even though these systems may have a negative effect on safety of people?
Yeah, the two are different points. Blitzscaling is a comment about how you would run your company, not necessarily how you would build an AI-based system for a life-critical operation. So there are still significant errors, as you know, in machine learning systems that we tolerate. So they are advisory. But you wouldn't want to have a pure machine learning system in a life-critical situation, flying the airplane or whatever. You want it to be advisory to humans or to algorithmic computation that actually drives that.
Yeah, and most of these medical systems we saw, they work with physicians that are human or still in the loop.
Yeah, and I think for the next 5 or so years, until we can solve this accuracy problem, and there are a bunch of problems in AI around essentially their breakability. When do they break? How do they fail? Can they be attacked? Which are being worked on at a research level. Until that, these systems are best used as humans with advice.
Question?
Hi, Erik. Quick question. The more these technologies become prevalent, how do you see the future in terms of concentration of power, technical, technological skill, and wealth?
Well, all of these things are interact, but an example would be in the last 20 years, the biggest narrative is not our narrative, but the narrative of globalization and the lifting of a couple billion people out of abject poverty to what we would think of as lower middle class, right? So that's an amazing achievement. And at the same time, everyone is complaining about an increase in relative inequality, which is also true. So the question that Eric was posing earlier is, can we get the good as well as some more good on the other side? And I think there are ways of doing that. I think that many of these network platforms tend to produce single or a few winners, right? And at least in global networks, there can be a global winner, and this is what you're seeing in the industry overall. The reason not to worry so much is that there's so much competition and there's so many new entrants that there's a pretty good likely of intense competition, right? Whether it's from China or from other countries or from new platforms. And these new platforms, the technology diffusion is so fast that I'm not so worried about this.
Do you see the competition mainly coming from other, like Amazon competing with Google, or new companies that we haven't seen before coming in, or both?
I think it's both. These tools are so powerful, and the barrier to entry to the markets are so low now. Right? Remember that when I was doing this, you had to have your own data center, your own computers, and so forth and so on. Now, using, for example, Google Cloud, you can build a whole infrastructure that scales, right? And in fact, the math is that it's cheaper than building your own.
Well, you can use the infrastructure, but earlier we talked about how data is really the lifeblood of machine learning. Will those small companies have enough data to do the machine learning they need to do?
It's an open question. There is research in trying to figure out how to get these algorithms to conclude with the right answer with less data, right? In other words, they need less training data, which would address some of this.
So some of that's happening. They're
some of that's happening. And the other is that there's a great deal of data that's not unlocked yet. In my personal philanthropy, I have a project called Data for the Public Good. What we're trying to do is to get data that governments and cities and so forth have and get it unlocked for public use, that is open source use, so that will then create additional new company opportunities.
The flip side of that is some people say that tech is ushering in a surveillance economy, an end of privacy, and that there's too much data that companies are gathering. Is that a fair criticism, or do you think? I think wasn't it Scott McNealy who said that we have no privacy, get over it?
Yeah, that is his most famous quote. That was 1997, so 20 years ago, well before all of this, and I know because I was there. I think the privacy concern is one that we're going to have more or less forever, and the reason is that we are so interconnected that we really do know a great deal more about what other people are doing. In many cases, because people tell us, right, through postings and so forth and so on. And I think that the most likely scenario is a combination of sort of good judgment by the companies and then regulation in the case of bad actors. And I don't think that's an answer that's any different from 10 years ago or will be.
But isn't the power different now? I mean, my mobile phone is reporting where I am and who I'm talking to in a way that never happened before.
That's actually, I know you think that, but the fact of the matter is that the mobile phones under the analog world reported exactly where you were for 911 services.
Well, depends how far back you go. We didn't all have mobile phones 30 years ago or 20 years ago.
But when you chose to have a mobile phone,
once you have a mobile phone, the towers have to know.
And the towers have to know, and it was the government that did that. That predates the smartphones. And at least for Android, we make a point of not storing that information, and that's part of our policy. So that's a good example of good judgment in that area.
Okay, so that's something that you do voluntarily. Or is there a regulation about that?
As far as I know, this was a voluntary move, but it was also, you could imagine that if we didn't do that, somebody would decide to regulate it.
Preempting it.
So sometimes well-run companies anticipate the bad activities that might occur from what they do, and they moderate their behavior, or they put in systems that protect people to avoid that.
Is that a healthy balance that you have people in government or activists or others that are sort of warning you not to cross certain lines, or do you think that's gone too far?
I think it's a pretty healthy balance. I mean, it has been our life, for the 20 years I've been associated with the company. It used to be that Google would just throw things over the wall. That's why we would beta test things. And now there is a pretty thorough release process to precisely address that
on that side of things. Yeah. Well, I'm afraid we're just about out of time, but I wanted to ask one last question, which is, I mean, you've had an amazing career, and we touched on some of the early days and some of the icons and the amazing companies you've been involved with. You and I were at a talk, an amazing talk by Arthur Brooks, and I think it's on tape now. You guys should all see it, about how to get happiness at different stages in life. And I could tell, I was sitting there with you, you were quite moved by that talk. How are you looking for happiness in your next stage of life? What's next for Eric Schmidt?
So the principles that we've talked about are true and will be true going forward, and I've decided to set up a set of philanthropies to focus on them. So for example, consistent with your innovation challenge, I've set up a group looking for using data to improve middle incomes, right? And we have various ideas about how that might work, but the goal is increase incomes by $10,000 for people who don't have college educations, right? So what are the tools, what are the techniques? We have a prize for that. So funding in that area. The biggest, I think, focus for a while is going to be AI acceleration, which is precisely what is going on here at MIT. Basically, can we use machine learning and AI in fields that have not had it so far? What do we have to do? Let's fund them, let's hire the people, and so forth, to bring those tools and techniques to science.
And you are going to be involved with MIT in particular on that. I know your Raphael has been talking to you about that.
Yes, very much so.
Great. Well, that's a good note to end on. Thanks very much, Eric.
Okay, thank you all.